Hello and welcome to a beautiful sunny day in Thailand in the hottest month of the year. That's why I'm inside, along with the you-know-what that's still in the air, and we're having a big flare up here in my town. But we're not here to talk about that. We're here to talk about this. If you, like me, have one of these really sweet microscopes, you probably have a cheap LED ring that goes around the bottom of it. Now, it doesn't look too bad. If we look at it from the side, I can see all of the component designations. I can see the parts. Everything's evenly colored. But if we look over here on the image that's coming out of the microscope, right in the center, I'm getting a tremendous amount of reflection to the point where you can't read the component labels. And then around the outside, it's dark. So we have a very uneven application of light to our board. In the center, it's shiny and reflective and unusable. And around the outside, it's dark and unusable. But boy, do I have some good news for you. The good news is there's a guy called Steve Gardner on YouTube. SDG Electronics is his YouTube channel, and he has designed a replacement for that LED ring. This one has 4 high power LEDs, all held in a 3D printed bracket with adjustable angle control on each of the LEDs. And it gives us an image quality like this. It's bright edge to edge. There's no shiny parts. Every single component value is readable, even down to being able to read the value of each component. This is outstanding. This is my ESP32 Mango board, and on the screen it looks like this. Even with the black board, everything is readable, no dark spots, no shiny spots. It's just beautiful. And at the end, I'll tell you how you can get one of these for your very own. Just hang on through the description and the build, and all will be revealed. Now, I want to make clear up front, I have done no engineering on this. It's all Steven. Here he is. Here's his channel, SDG Electronics. And in a series of YouTube videos, he has designed an LED microscope light replacement and gone through a few revisions and enhancing his design along the way. And at the end of the project, Steven decided he didn't want to turn it into a product, but he did make available the PC board layout files, the Gerbers, and also the 3D files for 3D printing so people could make their own. So I decided to build one. And then when I started looking at buying the parts, and if I needed 2 of these and 1 of these and 4 of those, I thought, well, why don't I just buy enough parts to make 10? I'll make one for myself, and then I will make the others available to all of our friends with this type of microscope out there on the wild, wild internet. And there's more detail about how you could get your hands on one of these at the very end. And as I worked through this thought process for building 10 units, I explicitly reached out to Steven and asked him if this was okay with him for me to buy the parts, use his designs, build the units, and provide them to our community at cost. And he said, yes, everything looks good, go ahead and do that. Okay, let me just quickly walk you through all the YouTube videos he did on this, the board and the LEDs. I will have links to them all down in the doodly-doo so you can watch them all to your heart's content in chronological order. This is the first video where he introduces the concept of the project. It looks nothing like this now. He's evolved it significantly. The next one is he was looking for parts and the initial schematic version. The next video, he's doing more schematic and PC board layout. The next one, he's designing the LED boards for what's called panelization. This is where you put multiple boards on a single board that the PC board manufacturer makes for you. One minor problem that Stephen had was when you do this, you basically want to make a way to easily snap the board out of its frame. But the first revision that Stephen did, the little snap tab was too small, and he accidentally uploaded that one for us to use. But JLC PCB rejected it because the tolerances were too tight for their equipment. I pinged Stephen, he immediately gave me the proper version, uploaded it to JLC PCB, and it worked fine. So we worked through that small problem. The next one is he actually used JLC PCB's new component assembly process. In this video, he walks through how to make the files for that so that JLC PCB knows to put what part where on your board. Now he's doing some more analysis about how JLC PCB manufactures your board, and he goes over all of their factory tolerances for drilling, spacing between components, spacing to the edge of the board, that kind of thing. Because you don't want your board rejected because this trace right here is too small. The next one is he has received the boards back from JLC PCB, fully assembled, except for the through-hole components, the switch, the dimmer, and the power jack, and it doesn't work. So he goes through, in this video and the next video, he goes through some analysis to find out why the tiny little LED driver chip seems to be failing randomly. Some of the boards work, some of them don't. Here's where he gets the boards back for the LEDs, and you can see the new version of the snap tab, which is exactly the way JLC PCB likes it, and he's testing them. The next video is he's designed and printed the bracketry that holds everything in place. This is an early version. He's gone through different versions from there. And this is where he does his initial assembly and puts the LEDs in place and finds out that it's not really an optimal design. He actually tests other LED board designs and goes with an aluminum board that's very, very thin for heat dissipation, because those puppies get hot. In the next video, he actually tests different LEDs with different lenses to see how effective they are, how much light they throw, and he's got a lumens tester that he does all this for. And then the last video is a fully assembled unit, shows how to attach it to your scope, and does the final testing. And this is what the system that I have built looks exactly like this. It's his final version. So I thought I would start the build with the easiest part, which is the little LED module. And we need 4 of these. You can see the boards come panelised from JLC PCB, and the board has an aluminum base for wicking away the heat, which Stephen determined is the way to go. They're also much, much thinner than standard boards. So you can see the design is straightforward. The LED gets soldered in here. There's a small 2.2 microfarad capacitor there, and then power and ground supply the LED. Now, the cool thing is, you snap these out. Each of them goes into a 3D printed little holder bracket. That holder bracket is designed so that this massive heatsink gets glued into the back of the board, which you can see here. You can see the giant way we're trying to wick away heat. This heatsink is held in place by this heat transfer adhesive tape. This is the smallest roll I could buy on the planet You don't want to know what this cost me. And then on the front side of the LED goes one of these lenses, and that is to shape where the light falls out of there. And the heart of the system is this LED. This is insanely bright. You get 4 of these coming in from each compass direction. You've got all the light you're ever going to need to work on your project. So let's go ahead and build one of these and see how it goes. I did not request the stencil for this. I thought I would solder by hand. We'll see how that goes. My initial plan is to float some solder on the anode and cathode in the heatsink, and for the cap, then I'll place the parts on and then heat them from below with the hot air gun. Now, I probably will refine this technique, but we'll see how it goes. Okay, that actually worked pretty well, although it took a lot of heat from underneath to melt the solder. I put the LED on, held it down with a tweezer, let it cool off, and then it was good. I put the capacitor on, then I buzzed everything. There's no short circuit. Everything goes to exactly where it's supposed to go. Now, here's the test. I need the LED is spec'd for 6 volts or 12 volts. So I decided I'll try it at 6 volts. And I just happen to have this battery pack that you might remember from a video from long ago. And if I just tap into the first 3 cells, it gives me just over 6 volts. So all I need to do, and luckily the contacts are about the same distance, all I need to do is touch right here. Ah! Jeez, it's like the surface of the sun. Damn, that's bright. This is just insanely bright from that little LED. That poor guy. Wow. Ow, 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 ow. And the back is hot, hot, hot. So, that's why we need heat sinks, baby. All right, let me get the other 3 set up. Okay, that was fun. All 4 of the LED boards are built and tested. Now we'll put the lens on. We'll see how that goes. This just peels off the backing, and you'll see it's got 4 little posts in the corners, which should fit into the 4 little holes on the LED. And this is probably a one-time thing to get that in the right place. And there they go. Squeezy, squeezy, lemon peasy. Is that how that goes? Cool. Okay. Lenses are on. Next step is to solder the power supply wires, as Steve shows in his video here, and I'm just double checking myself. Then what you have to do is run the end of the wire through this tiny little slot, which gives you something that looks like that. Now, I've got some nicer wire than this. This is 24 gauge. It's all I've got that'll fit in that slot. I hope it's enough. Then I screw the back plate on. Steve's using these black self-tapping screws, which I don't have. I have really poor supply of specialty hardware, so I have to basically mail order everything. I've got these cap screws that I used that are the right size, but I don't have enough. I don't have 16 of them. So this will do for now. Then the last step is we put a piece of the thermal adhesive tape onto the heatsink and stick it on. And there we have them. 4 LEDs, lens mounted, heat sunk, and partially screwed and wired and tested. Now we get to go over to the driver board. Okay, now we get to jump into the driver board. The whole point of this board is to have power coming in, an on-off switch, a dimmer control, and generate the voltage and current sufficiently to drive the LEDs. And the heart of this board is an LED driver chip, and then all the associated passive components. Now, of course, I bought my board raw, and a crap load of components from suppliers around the world. Stephen actually used JLC PCB's component board assembly service, which I haven't tried yet, because where's the fun in that? We get to solder stuff. So let's get cracking on all the surface mount components, and then I'll put the through-hole stuff in afterward. And yes, I did get the stencil for this one, and there's quite a few little parts that go on here. Okay, the solder paste went on beautifully. No smears, no runs, no messing around. All right, let's place some components. Okay, all the components have been placed. Strange thing, 7 of the little 2.2 microfarad capacitors that were on the bill of materials do not exist on the board. So another slight mismatch in the design versus reality. But we can work through that. Now let's heat everything up and get them all soldered. Okay, how'd we do? Well, little diode over here just blew right off its pads, and this capacitor and these 2 inductors just refused to hot air solder. So I did them with the soldering iron after. It'll be a miracle if this works, because there are 4 diodes on the board. The diodes themselves and the board are not very well labeled as to the orientation of these diodes, so it's going to take a miracle for this thing to work first try. Okay, I put the through-hole components in, the power switch, the dimmer control, and the power jack. And as I was admiring my handiwork, I went, oh look, there are the missing capacitors. He just didn't have room to put them on the top of the board, focus, so he put them here. Okay, so one small last bit of hand soldering, because I do not have a stencil for the back side. My bad. Okay, the missing capacitors are now soldered in. Everything looks good, but I am going to go to sleep now. And in the morning, I will check for short circuits between power and ground. I'll check every solder pad. I'll buzz things out as much as I possibly can. I'll apply some power here, and we'll check and see what's going on, because I do not trust myself right now. Always sleep on it before you make a big commitment, like plugging power into a new project. Okay, it's the next morning. I buzzed out power and ground. I didn't find any shorts. All the solder connections look good. Without the LEDs, I plugged in power. The LED lit up here, and everything looked good at the right places around the board. I was following along with Steve's schematic design. But then I attached one LED and it didn't light up, which got me worried. And then I realized that I think you have to have 2 of these LEDs paired together so the current flows through a double serial series, and then the other independent LED driver also has them in a series. So there's no way to test this without a real LED. So I plugged it in. We have power, and I turned the switch, and we have light. Look at that. From a little bit of light to a lot of light. And I mean a lot of light. This is overwhelming, and it's just throwing off heat. I mean, I can hold my finger on it, but after a while that's going to get pretty warm. But isn't that awesome? It worked first try. So I had my LED, or all of my diode orientations were good. Shocking. There's a 50% chance of getting something wrong. I'll pick the wrong 50. Okay, so I have the frame bracket 3D printed. So let's get this mounted up. Now I've got each of the light modules mounted in the 3D printed plastic bracket. The driver board is sitting in its bracket, just like Steve is showing. And as you saw in the intro, I now have the light completely assembled, and the brightness control is here, depending on how much light you want to throw on it. My camera system has an automatic exposure, so it doesn't affect it that much as I adjust the light until the camera just cannot make up for it. So you do have quite a wide range of brightness to choose from. Okay, now that we've seen the light ring built and working, as good as I can get for now, I'm going to show you how I came up with the cost model. So what I did is I took Steven's bill of materials and put it on steroids. And I've got a line item for every single part, and I'm pulling parts from all over the world because that's kind of what you have to do on a complex project like this. So I had some stock of some of the common 0805 resistors and capacitors. LCSC is coming from Shenzhen. Mauser and Arrow are coming from America. Element 14 is from Singapore. JLC PCB is from Shenzhen. My 3D printer is right over there. And Lazada stuff is coming from somewhere in China. Anyway, so what I did is I've got a description for each part and the identifier on the circuit board, the footprint that I used in the to decide which part to order, because certain parts come in different footprints. If there's a manufacturer part number for a non-generic part, I have it. Then this is the part number for the supplier that I ordered it from, because like LCSC, this is their part number, but it refers to this manufacturer number. Then I've got two more columns, and the number you see is in Thai baht. This is the price of buying one of the parts, and this is the price of shipping one of the parts. So I took the total invoice, divided it by the number of parts I ordered, so I did all the math. Each of these line items represents the cost for one part. Some of them have free shipping, some of them have very cheap shipping. Some of them from America came by FedEx because that's the only way they come. The shipping is more expensive than the part. So this heatsink coming from America by FedEx was more than the price of the heatsink. Anyway, then I calculated the cost of each of the 3D printed parts by how much electricity it used and how many grams of filament that it used based on these standard numbers. And the remaining things are the hardware to bolt it all together. And these are 4 bolts, 8 bolts, 12 nuts, and 16 self-tapping screws. So the grand total, including shipping, is 1,431.34 baht, which translates to $47.71 US, which I think is a tremendous bargain for what we're getting in this project. It's outstanding value. Now, say 9 of you very lucky people who are desperate to get one of these in your hands. How do we go about it? Well, probably the easiest thing is to send me some money on PayPal. That's one of the only ways I can receive money. If you have another idea, let me know and we'll see what we can work out. This is my email address, mwbrown42@gmail.com. What I'm going to ask is if you do send by PayPal or another transaction system that may add a fee to it, I don't want to have to eat that fee. So let's round $47.71 up to $50. And that way we're working in very even amounts of money. Now, I want everybody to realize I'm doing this for fun and for the benefit of the community, but I want people to realize that I spent dozens and dozens of hours working on ordering everything, putting the BOM together, making sure it was accurate, chasing down parts. I'm actually in a transaction dispute over these LEDs. And then also the complete assembly that you saw me document here. So let's have a gentle person's agreement. $50 rounded up for the parts. Then whatever you think is in your heart to throw me a few more bucks for the time and sweat and blood that I have put into getting your package to you. Also, I need to append to this, plus shipping. Remember, I'm in Thailand. You are probably somewhere else in the world. Email me first. Tell me where you are. I will give you a price for shipping based on how fast you want it. We will make that the base amount that you will then get to me using some sort of a transaction system. Again, I'm only doing this for 9 units, so go ahead and email me. We'll work something out. Okay, so I think that'll wrap it up for this. I hope you've enjoyed the project, and I want to again thank Stephen for all the time he put in on the design of the circuitry and the layout of the circuit boards and the 3D models. I am standing on the shoulders of a giant named Stephen to actually get you his vision for this project. So email me if you got any questions. That way I will see it. Don't put anything down in the doodly-doo about wanting to buy one. Email me directly, please. Okay, that's enough for today. I'll let you get back to your life. Hey, if you found this video interesting, please give it a thumbs up. And if you like my other content, I'd appreciate a subscribe. Take care and see you next time.